Number 17 from the Unit 7 review here. I'm going to solve this for x. So I'm going to start by thinking of PEMDAS backwards. I know x is on the left-hand side, and so I'm thinking what can be added or subtracted to eventually get that x by itself. I'm going to start by subtracting 5 from both the left and the right. These cancel, and I have 2 times 4 raised to the 3x minus 5 equals 12. And then I'm going to work on adding, multiplying and dividing. I have 4 raised to the 3x minus 5. I did it to the left. I must also do it to the right-hand side equals 6. Now, I'm rushing here to try to get through this. I want to make sure I just don't make a small mistake. So give me 1 second. Subtract 5 from the left, subtract 5 from the right. All of that looks great. And then I want to divide by 2, and I want to divide by 2. Everything looks good. The whole purpose of logs, why they're created, is so that when you have a variable in the exponent position and your mental math can't get you that answer real quick, we use logs. So in this case, this is how logs work. I'm going to do what I want to get rid of. So log base 4, and whatever I do to the left, I must also do to the right. The exponent, whether it's just one number, a variable, or expression, is going to pop in front. 3x minus 5 times log base 4 of 4 equals log base 4 of 6. This equates to 1, and 1 times this quantity is still 3x minus 5. I don't know what log base 4 of 6 is, so I'm going to get this answer, but I'm going to do that later on. Let's first just continue to try to isolate the x. I'm going to add 5 to the left and to the right. Make sure to put parentheses around here because this is one quantity. We'll add 5 afterwards and divide by 3. So x equals log base 4 of 6 plus 5 divided by 3. Now, if they ask for an exact answer, this is it. Don't change anything about that. If they asked you to round, then we're going to practice that right now. So I'm going to go with math going up 3 times. And then my base is 4, the number behind it is 6. I want to get that answer, then I want to add 5, and lastly I want to divide by 3. So if I had to round it, it'd be 2.097 to the nearest thousandths. And as I said earlier, I will always tell you in advance what I want you to round to if it's going to be a decimal answer. Let's look at number 18 before we flip to the back side, and we have 3 more problems. Okay, we want to solve here, so I want to get this portion right here that I'm underlining by itself. So I have 3 times, and I'm going to be lazy. That's this portion plus 8 equals 20. So to get this portion right here by itself, log base 2, I don't want you to do that on the test. I better write it out. I'm going to start by subtracting 8 to both sides. I have 3 times that quantity, log base 2 of 3x plus 5 equals, in this case, 12. I'm going to divide by 3. My pen is running out there. I have log base 2 of 3x plus 5 equals 4. Okay, now I'm going to write this in exponential form. So 2 raised to the 4th power, 2 raised to the 4th, equals this quantity, which is 3x plus 5. 3x plus 5. Okay, 2 to the 4th. That's not 2 times 4. It's 2 times 2 times 2 times 2. That's a total of 16 times. And now I'm going to subtract 5 from both sides to get 11 equals 3. Let me see what I just did here. 16. Did I write anything down wrong here? Oh, here's my problem. This is subtraction. Make that subtraction. Make that subtraction. Make that subtraction. Make that subtraction. That's my problem. This original problem was subtraction. I accidentally wrote addition. So I'm actually going to add 5 to both sides. So when I add 5 to both sides, I end up with, now let's make sure, again, I'm not making any mistakes here. I end up with 21 equals 3x, divide by 3, x equals 7. What we do need to make sure is we're checking for extraneous solutions. So you're thinking, what is she talking about? I've heard extraneous solutions, but I don't know what she's talking about. So we have values here. These values can never be negative. So if you plug in a value of x, plug in a value for x because x is one of these positions, it can never equate to a negative number. So I can see that x was in the back position, so I'm going to plug in 7 and make sure that when I evaluate it, this spot is not a negative number. 3 times 7 is 21. 21 minus 5, it's not going to be a negative, so 7 is the correct answer.